Morning. So I'm out here measuring things out for the backyard vertical project. Thought I'd show you what I'm up to. Went and picked up a bunch of stuff this morning at the hardware store, and I had some donations off of Patreon from guys, direct donations that I've been saving up, and I really appreciate that because they paid for the materials for this project, and so that's working out great. Alright, so here's what's going on. Now this is the corner of my basement window here, and I've got a ground wire going in there already, and that's where the coax is going to go in for the antenna. And right here is a 6-foot piece of angle iron that's driven into the ground as a ground rod. And this is a piece of, or this is 3 pieces of PVC pipe. And I was just measuring it out, and I've marked the pipe right here where I'm going to cut it. And this is going to be buried down about 5-6 inches into the ground, and it's going to run straight out this way to the shed. And here is where the base of the antenna is going to be, right below the peak of the roof of the shed. So what's going to happen is I'm going to have the pipe come up out of the ground there with a little corner piece for the coax to come out, and I'm going to drive a ground rod in right there. And the ground rod is going to be the base for the mast. I've got a rubber boot and some hose clamps to clamp onto the ground rod. And then up here at the peak of the roof, I'm going to 3D print a clamp that's going to go over the mast to secure it to the side of the shed here. So the shed's going to provide the additional rigidity to hold the mast up against wind loading. It's a wooden shed. There's nothing metal inside the shed here to get in the way or to interfere with the antenna. So then from this point down here, the ground rod will be the basic ground for the ground side of the 9-to-1, and then I'll run radials off that'll bury an inch or so underground that way, and off the down the driveway that way, 33 feet, equivalent to the length of the radiator, and under the shed out this way. And yeah, I've got a hill back here it's going to have to go up, so that's going to deform the back radial and screw with the radiation pattern off in that direction, but that's okay. We'll get as much wire out here as we can. The only short side that I've got a problem with is going in that direction, towards the north. I can only run a little ways for the radial before I hit the neighbor's fence, but that's all right. It'll give me a little bit weaker radiation to the north, but I'm not too worried about the north. That way is south, that way is west, which will have the longest radials, and out the other way then is the east. Well, Mother Nature didn't cooperate. It was nice yesterday, it was in the 60s. Now today it's 40. We're putting in the ground rod. We got a hammer drill, and we're down to 4 feet. We got 4 feet in the ground. Just plugging away at it. Digging a trench. We got, well, thanks to John's efforts, my back, there's no way I could have done this. Much appreciated. He's dug from the house.
Tom Sawyered my ass. He said this would be fun.
I'll probably have to bleep that.
This ain't fun.
The ground's full of rocks. But we're almost there. And while he's covering the pipe back up, I'm going to start working on the mast. I might actually get this antenna on the air tonight. So while John's still working on the trench, I'm prepping the mast and the antenna. And these are telescoping masts. They've got a small section inside of a larger section. And you pull it up and kind of twist it to lock it in. And they make clamp kits for these. But what I'm going to do is I'm taking some black vinyl tape, I'm just going to wrap a layer around where the seam is, then bring the wire in and put another layer on to hold the wire against the antenna. And we'll do that all the way up. And that should keep the thing from collapsing on itself down the road. And as I've said before, this is only a semi-permanent installation. So for all I know, I might end up having to vacate the house this fall. We'll see. So yeah, I'm just going to put a little layer of tape around across that seam. And then bring the wire in and put the layer, a couple of wraps around the wire. And we'll just do that all the way up the mast. And we'll have our antenna. So what we're doing, before we glue the pipe, bury it, we're going to run the coax through it. And since I'm only going to have about 4 or 5 feet of coax at each end of the pipe, well, less at the antenna end, only a few inches, and about 5 feet at this end, I'm going to push the coax through the pipe, leave a couple extra feet there and a couple extra feet, now 6 or 7 feet on this end, cut it, and then we'll just put the fittings back on from the short end of the cut coax, and then glue it all up. So, no need to do anything fancy. We can just run the coax right through. So here's the base of the semi-permanent installation. We've got a rubber boot there on the mast to protect it, and a couple of hose clamps clamping it to the ground rod. And that's the PVC coming up. We haven't glued that top part yet. Clamp to the top of the shed there. And that's an experiment. We're going to see how well this holds up with the wind. And there she is, way up there. Let me walk back here and show you the money shot. There's John tamping down the dirt on the trench. And there she goes. Now those power lines back there that you see, they're about 80 feet back. It's a 33-foot mast, so no worries there. My AC electrical line's over there on the other side of the yard, and that's about 30 feet away. But it's insulated wire and it's a fiberglass mast, and the phone lines, the old phone lines, are in between, so I'm not too worried about that. If it fell that way, it would careen off my end-fed wire and the phone lines, and even if it hit the AC line, it's just fiberglass and shielded wire, so it wouldn't do anything. It'd just fall over, fall past it, flex at the tip, and hit the ground. So all we've got left to do is glue on the ends, run the coax in the window, put in a PL259 on that end, and I'm going to zip tie the feed point on there, hook the wire up to it, hook the ground to the ground stake, and even though I don't have the radials in yet, that'll be enough to start testing the antenna, because at that point it'll be a upsized duplicate of my quick and easy field antenna, and the coax will provide the counterpoise, or enough counterpoise at least, to load it up and get on the air with it. And then over the coming week I will bury some radials, probably one per day, because that's about all I'm going to be able to do. This is just killing my back. Even the little bit that I've been doing today, John's been doing all the heavy work as he sticks his tongue out at me. Yeah,
we told me I wouldn't get dirty.
Yep. Well, I got a Band-Aid sliced through my hand with the razor knife while I was putting up the mast. Oh, that always happens though, doesn't it? Anyway, that's where we're at. Just buttoning it up. I have an antenna. I've got ground connected down here to the ground stake. There's a radiator wire going up. Coax is hooked up at the base there, sealed, and going up through the PVC. I'm going to stick some foam in the ends of the PVC to seal it up. And I'm going to water this trench tomorrow so the grass can keep growing. Over here, kind comes out next to this ground stake. And what I'm going to do is take a length of wire and just wrap it around this coax real tight and then connect it to this ground, and that'll be like a spark gap. And then inside there will be a connector so I can unhook the antenna when I'm not using it, or if there's storms coming, and that way if there's a lightning strike, hopefully most of it will be taken care of by the radials and the ground rod, but anything that comes over here will flash over to that wire that'll be wrapped around the coax and into this angle iron that's my ground stake here. So that should at least minimize damage if there's a lightning strike. And as you know, lightning's always fun with antennas, but there we go. It's up at least for testing now. No radials yet. I'll be doing that over the coming week, but we'll get that hooked up inside to the radio tonight, and we'll see how it tunes up and maybe do some whisper transmissions. Well, back out here today, laying some counterpoise wires. You might call them radials in a regular vertical. And this antenna, I don't know, they're kind of radials, but they're really counterpoise for the 9-to-1. So they're all going to tie to the ground lug on the 9-to-1. And I'm just cutting a little notch in the ground with the shovel. And I'm going to use that paint stick there to shove the wire down into the notch and just tamp it over. So that's the plan. Well, we've got the vertical hooked up. I've been doing some testing with it. I wanted to show you the difference between it and the end-fed wire. And the end-fed wire is 98 feet, goes up over the house down to that shed in the back. And it's always done pretty well. But here we are listening to a WWV on 10 megahertz. It's 10 o'clock in the morning here. And you can see there's a little bit of fading, and it's hovering between S7, S9, somewhere around in there. Now I'm going to switch to the vertical. Actually, that is the vertical, sorry. So that's the vertical. Here is the end-fed wire. Quite a difference. I mean, S3, S4 to S5 or 6. Here's the vertical. You can see that comes right up. Let's go up to 15 megahertz. Now that's the vertical. There's the end-fed wire. It only dropped down a little bit up here at 15 megahertz. Vertical. End-fed wire. So it's still outperforming the end-fed wire quite a bit. Well, not quite a bit, but it is outperforming. Vertical. End-fed wire. Vertical. End-fed wire. So there's definitely an improvement with the vertical. Well, I'm real happy with the antenna. It's Whispers back here right now doing some beaconing, and I'll throw the results up here on the screen for you here momentarily of the stations that have heard the beacon. It's set at 500 milliwatts, just half a watt. That's my usual power when I do whisper. I try to maintain that standard for myself so that I have sort of in my head a baseline understanding of what type of results I see with the different antennas that I have. The antenna's been working very, very well. I've made lots of contacts on 80, 40, 20 meters. Haven't done anything on 15 and up yet because the bands just haven't been open. 17 meters hasn't even been open, but it's only been a few days. I did bury some radials out there, at least 3. You could call them radials. They're really kind of counterpoise because it's a 9-to-1 un-un. It's not a classic vertical. It's not intended to be a resonant antenna. It never was. It's intended to be a flexible antenna and require an antenna tuner to operate with. So before anybody out there wants to start harping at me that you should do this or that to make it resonant, sure. You know, there's ways to make resonant verticals with tons of radials in the ground, and they're great antennas. But this is an antenna that I just wanted to get up as something on the cheap, a budget antenna, simple to put together. simple to get up, and flexible and capable, and that it is. I have made lots of contacts on 80, and it's done far better than my end-fed wire has ever done, with reports from several states away of 10 over 9 with my 100-watt barefoot radio. I've done low-power contacts. I've worked across the country with the QRP with 5 watts with it. It's outperforming my end-fed wire by quite a bit, and in fact on 20 meters, it's even outperforming my resonant 20-meter dipole, which is an attic dipole, but nonetheless, this is the best performing antenna that I have now. And I'm really looking forward to doing an HF hangout this coming Saturday with it, and we'll see how we do making contacts with viewers, with you guys on the air. Now, some notes on the design. I'll draw up a diagram and put it up here on the screen. The main mast is an MFJ 33-foot telescoping mast. The antenna wire itself is just some 18-gauge hookup wire that's insulated, running up the side of it. Now, the matching network at the base that I've put in PVC, originally my intent was to have a 9-to-1 un-un auto transformer, and then a few inches away from it, a 1-to-1 common mode choke to cut down on RF coming back on the coax. Now, strangely, and I do not know why yet, this is just baffling me, with the 1-to-1 common mode choke in there, it just killed the antenna. Receive went down the tubes. Everything was hardly tickling the S meter, even WWV, and it just did not want to load up. And I'm completely perplexed by that. My end-fed wire has a 1-to-1 common mode choke on it. I've used it with dipoles. It's always been a big improvement on antennas, but for some reason, and I've tried a couple of different ones, I even wound a new one and tried it, it just kills this antenna. And I guess it must be some relationship between the length of coax. I've got about 40 feet of coax coming back to the radio. Some relationship between the length of coax and the radiator and the 9-to-1 that for whatever reason the common mode choke just completely kills the antenna. So I took it out. So in this design now we just have the 9-to-1 unbalanced to unbalanced auto transformer. And it's the same exact design that I wound in the previous video. In fact, I used that exact one when testing the antenna, and got exactly the same results as the one that I have out there now. So I'm just leaving the common mode choke off. I don't see a lot of RF coming back on the coax. I've put my field strength meter next to the coax here and hardly seen anything. I think burying it underground might have something to do with that, but again, that's just speculation. It definitely seems to be working out. So, the mast is 33 feet. I've got about 32 feet of wire running up the mast for the radiator. With just that and the 40 foot of coax coming back from the un-un, the antenna performed great the first night that I was testing it. I didn't see much RF on the coax. I got out wonderfully. I made contacts on 20 and 40 meters and 80 meters. I did some whisper testing, and it just really got out well. So it seems to work just wonderfully without any ground radial system at all. Just the ground rod at the base. Oh yeah, ground rod. I have an 8-foot ground rod. We were able to drive it down 6 feet into the ground. So there's 6 feet of it underground. And then I cut it off with about a foot sticking above the ground. And that's where I attached the mast. Now the mast is attached with a rubber boot around it. It's just a plumbing boot that you can pick up at your hardware store that they use to put over pipes, and a couple of hose clamps. And that boot's protecting the surface of the mast and holding it well against the ground stake. And then up on the peak of the roof of my shed, I printed a clamp and have just clamped it there to the top of the shed. Now, it's a very lightweight mast. It really doesn't weigh much at all, and it's not going to present very much in the way of wind loading. There's no real weight on it with just the one wire. So I'm fairly confident that it's going to hold up just fine for short term, maybe even for a year or more. I've always thought of this as a temporary or semi-permanent installation because I don't know if I'll be in the house, next year. So, it should be fine for me. You might want to do something more rigid if you're putting the antenna in permanently. That's completely up to you. The basic electrical design is a 32-inch wire going up, a 9-to-1 un, and a 30 to 40 feet of coax coming back to your radio. Is the most basic way of looking at this antenna. So anyway, I hope you enjoyed this video. I'm enjoying the antenna, and perhaps we'll get a chance to talk to a few of you on the air in a few days. Well, actually, this video will be going live Thursday night, I think. So it would be in 2 days. Then on Saturday morning, that we'll be doing an HF hangout with it. That is if it survives. Actually, a really good test for this antenna. This Thursday, we're supposed to get thunderstorms and high winds. So that'll be a real good test for it. Any other details? Let's see. Where it came into the basement window there, you saw that I have a ground stake. And I'm wrapped some wire around the coax and then attached that to the ground stake. And that's sort of a flashover point. You know, lightning arresters are basically spark gaps anyway. Even those gas discharge lightning arresters, they've got the center wire coming through and then a small gap and a tap that goes to ground. And then the idea being that a lightning surge would bridge over that gap. So I thought, hey, same idea. I'll just wrap some wire around that coax, and the shield of the coax provides the gap, you know, and if there's a lightning surge, it'll probably jump to that wire and go right to the ground stake. It's not gonna hurt. It might not help tremendously. Maybe it will. I don't know, but it's something. And just inside the basement window there, as you saw by the picture I put up in the video, I took an old metal film canister and I put a BNC panel mount connector on it, and then a BNC connector on the coax that goes up to the radio. So that's my disconnect just inside the window. So if I'm not going to be using the radio for a little while or there's storms coming in, I'll just go down there and just disconnect that BNC connector and leave the coax just dangling inside the window there. So that's my disconnect for lightning protection. And I think that's pretty much it. The radials, I didn't see really any difference in the tunability or performance of the antenna when I put in those 3 radials. I'll probably put in the 4th. My neighbor's given me permission to actually bury it into his yard. He says he doesn't care as long as it's underground. He doesn't care. So I'll get a 4th one in. But honestly, the antenna performed just great without them. And I don't see any real difference in noise floor or my whisper broadcast footprints or my making contacts with it, or the tuner, how the tuner's behaving. I really haven't seen any difference. I mean, the tuner wanted to tune to different settings, different inductance capacitance settings, but it tuned up just fine on all the bands in either case. So honestly, I don't think you need the radials for this antenna. No, it is what it is. Sorry, I've been talking too much, but there you go. I know this is a rather long video, but I know a lot of you have been really interested in this antenna. And we're going to do a few more things with it. Jim down in southern Indiana, who donated the mast, has one of his own. He's duplicating the antenna this week, and we're going to try to make a QSO from antenna to antenna. And I'll probably film that for you too. And you'll see other things with this in the future. It's going to be my main antenna for a while. It's performing so well. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.